Now this illustration deals with intrinsically safe systems. These systems contain a barrier that you see in the illustration. And notice anything on the load side of that barrier is protected. If you shorted out one of those intrinsically safe circuits at a terminal, or a conductor that carried that power got damaged, there's not an arc that would be produced that would exceed the ignition temperature of the gas or vapor where it was routed, such as the classified areas that we see to the left. Class 1, Division 2, Class 2, Division 2, Class 3, Division 1, Class 3, Division 2. But notice intrinsically safe can be used in any area that it's designed to be used. It's a system that is perfectly safe, but more maintenance is required. You have the barrier, you have the conductors routed, cables routed back to the computer in the area. And notice we tell you also see page 21-16 in volume 2 of the Stallcup's design book for a lot of information pertaining to intrinsically safe system. But they can be used in a Class 1 or Division 2. They're recognized in NFPA 497, where designers will pick up the, say, the flash point of a liquid or gas, the ignition temperature, the lower and upper flammable limits, the density, does it rise or settle? The only place we can pick that information up is in NFPA 497 to start with. And notice that now in 500.4, the NEC, I believe it is, we're referenced to these standards that can be used with hazardous locations. The NEC just gets you started. You have to remember that the NEC in 500 and 501 on through that series will never classify the area completely. You have to use NFPA 497 for gas and vapor, NFPA 499 for dust, flyings, and fibers, and NFPA 496 for purged and pressurized equipment. But we are recognizing here an intrinsically safe system that can be used in Class 1, Class 2, or Class 3 in any division in which it is designed for, with the group of hazardous material that the components and the wiring and the cables and the devices and so forth are exposed to. So in the illustration you have the safe area, and if you place that barrier in an enclosure in the safe area, it can be in a general purpose enclosure. But if you happen to place it in the hazardous area, it has to be in an explosion-proof enclosure. Then you have seals and other things that kick in that you would find in Volume 2, Chapter 21, with illustrations that illustrate this in detail so that you really understand it in a greater amount of knowledge. But right here, we're just recognizing it as an intrinsically safe system that can be used in these areas.